sure.
Of course, no problem.
That's great. Thank you very much. Um, just
No
last,
problem.
yeah, just a moment.
Can I get the recording later?
Sorry?
Can I get the recording after we finish the meeting?
Yeah,
Or
sure.
it's just for okay.
Yeah, it's actually for I have to show that I have done the meeting, so just as a
Right.
record. I think.
Perfect.
Mm, just a moment. Yeah. Mm, so I'll be sharing my screen.
Yes.
Is my screen visible?
Not yet. Yes.
Yeah. So my name is you already know my name is Abdullah, and I am working I'm a master's student at Memorial University of Newfoundland, and I'm working on photocatalytic conversion of CO2 to methanol. So where we are using green photocatalytic technology in order to convert CO2 to methanol as a low carbon fuel for shipping and also for
Yes.
industrial use and for also in cars. So these are
Great.
the goals and missions. So moving on to the challenge. So as we know that the methanol production is overwhelming and increasing at a higher rate, and also there are different technologies for conversion or for capturing of CO2 and for converting it, and those are energy intensive due to atmospheric due to low atmospheric concentrations. And the maritime shipping sector faces pressurizing from the regulatory framework in order to reduce their CO2 emissions. So we came up with this idea of converting the CO2, which is dissolved in seawater, into methanol. So as we can see, so this is the diagram, and this is the diagram, and here we have the photocatalytic reactor in which CO2 goes along, and we have the photocatalyst. So this photocatalyst plays an important role in converting the CO2 to methanol. So the photocatalyst is visible light active. So when photons fall on it, it gets activated, and the reaction takes place by the splitting of the water, hydrogen to hydrogen and oxygen, and reacting further, it leads to the formation of methanol. So this is the part of photocatalysis. And we already know about electrocatalysis. It's like something further which we plan to do. For now, we are focusing on the photocatalytic technology. So this is the photocatalyst, and this is the working mechanism of the photocatalyst, which we produce by having two materials joined together using different synthesis part. Now, and the product which we have would be green methanol, and which could be used as marine fuels and also for fuel for cars, and also as feedstocks for production of other chemicals. And then we would even have green hydrogen, which is for a low cost energy input. And it would this is later on planned, because the reason we target green methanol is because of its liquid form and ease in storage as comparing to hydrogen, which is gas and very difficult or very dangerous to store. And we could have you so this is the dual revenue plan. So we have the green methanol and the green hydrogen as the product, and also we would be eligible for carbon credits trading. And so we know the global market opportunity for methanol is rising, and it exceeds like 100 million tons per year. And Maersk in Denmark has ordered methanol fired capable vessels. So those vessels which would actually run, or which could utilize methanol as a fuel. And so this is the process of direct air capture. And then we have the green premium pricing for the green methanol. And these are the advantages of our process, which is to reduce the CO2 and avoid um, tons of CO2. And yeah, that's all what and that's all from my side. And I would like to know, like, what is your current role, and what role do you play in the decarbonization?
Well, first of all, it's a very interesting project. I've never heard about it before, because that's not my area of expertise. I'm currently working at the Biomass and Bioenergy Lab at our National Agricultural Technology Institute. I'm
Yeah,
working on the integration between anaerobic digestion, biogas production,
yeah,
and uh, insect rearing. We have in the first process biogas production, the digestate that has different nutrients that can be used as a feeding substrate for insect rearing. The insect that I'm using in my PhD studies is the black-soldier frog larvae that can consume different organic waste and organic matter. And after that bioconversion process, we have biodegradable matter that can be used again in the biogas production process. Uh, Thinking about your project, although I'm that's not my area of expertise, as I told you, I'm working at this lab that we we use different this the main process that we investigate and do research on is the biogas production, but I think that I can talk with my mates, my colleagues, if we to see if we can give you some advice to analyze different opportunities of scalability of this project. Uh,
yeah, sure. That even that would be great. So if you could connect with some of your colleagues or whoever is working in this field, so I can have a meeting with them and then receive their feedback. Yeah. But it was great meeting you.
because what I think I'm completely convinced about is that green chemistry is growing around the world,
Yeah.
and this type of projects, biomass utilization or valorization, or even what you're working on, can no, it will grow in the future. So even we can continue working together to follow some synergistic opportunities between our my group and your group. So what I can tell you and do is talk with my colleagues
Yeah.
and uh, present them this project. That's why I was asking you about the recording, or even the slides, if you can send them to me, because we can give you some advice, or even with other colleagues that aren't in my group, but are that can be that can give you some piece of advice on what you're working on. And the main objective of this, I think, from my side, is the scalability and impact that can have
Yeah.
in the industry. What do you think about it?
Yeah, that's right. This is what I understood from having a meeting from different people. And scalability. Yeah, that's something which we are looking on. So now we have done this on a lab scale and we received good results. Now
Mhm.
we plan to move it on further to production of like 1 kilogram of methanol, but that would require a different kind of equipments, and that would cost us. So for that, we would also request the funding from the governments or from other research council institutions uh, who could help us in making the pilot plan for 1 kilogram for the conversion of 1 kilogram of methanol. And
Mhm.
yeah, and that's great that it would be great to connect with your colleagues and to have discussion on this. Um, what I can do is I can share a YouTube video link. So we up
Yeah,
we
sure.
yeah, we did this project even for one of the competitions. So we uploaded a like 6 minutes video, so we could share that video with you, so that
Mhm.
uh, you could send it to your colleagues, and that would be great for us. So it's just a
Yes.
6 minute video on the project and these same slides. Yeah.
So this project is part of a bigger competition. That's what
Uh,
I understood.
no, we
Ah,
actually, it was not a part, but we actually wanted to participate in it. So they required that we should upload a video as part of the application form, and then they would select from lot of applications. But
okay.
that program was actually scheduled later on and ended because of the conflict in Middle East. So we could not move further on that.
Okay. Yeah,
Yeah,
but if you have the that
yeah,
video
we
from
we
the
have the
competition,
video. Yeah, sure.
would be very useful.
Yes, it would be.
And even if I can contact other colleagues that are not in my group, in my lab, but maybe they are interested in working with this type of topics, or even from other institutes that are located in my city, Mar del Plata, that can give you some advice or even collaborate with you
Yes.
and your team. Uh, we are not specifically working on materials and this type of project, but I think that the scalability that can have in the future is big, as I told you some minutes ago.
Yeah.
So I would like to keep contact with you and your, why not your team or
Yeah,
your
sure.
group mates, and see the different opportunities that we have.
Yeah, sure. That's great. Thank you. Thank you very
It's
much.
a bit at pity that I'm not working specifically with these topics, because
Yeah.
I'm dedicated to process in the agriculture world,
Yeah, yeah.
but
That's right. Yeah. Yeah,
we
also
can explore together opportunities.
there are certain technologies even in for the conversion of CO2 using enzymes to convert it into uh
Mhm.
bio-based process for CO2 conversion. So that's what I heard from the previous interviews also. So enzyme
Yes.
based conversion. So converting CO2 into some other compounds, valuable compounds. All right.
Yes. This Friday, I have a meeting with my group,
Yeah.
so I will tell them,
Yeah, sure.
and then I can contact you. What do you
Yeah,
think?
sure. No worries, no worries. Take your time. That's great.
Mm.
Yeah, yeah.
Can I send you my cell phone so we can get in touch
Okay, sure.
easily through that way? Yeah,
Sure, no
I
problem.
will send it through the chat.
Yeah.
Mm. Okay, that's it.
Yeah, sure.
So when when we have some time and send me the video on YouTube for that competition that you applied would be great, so I can tell my
Okay.
my colleagues, right?
Yeah, sure. That's great. Nice to meet you, Dr. Prado.
Nice to meet you, and thank
Thank
you
you. Thank you
for
very
your
much.
time and your
Yeah,
presentation.
sure. Have a
See you.
nice. Bye.
Have a nice day.